Nearly 2 billion people consume alcohol regularly. But if you haven't heard, it's Dry January, where some people will take on the challenge of refraining from drinking any alcohol for 1 month. But will stopping alcohol for just 1 month actually have any significant health benefits compared to if you quit altogether? Well, today we'll discuss both of those scenarios and also address how many of the health organizations have recently changed their guidelines about what amount of alcohol is considered safe. Like they used to say 1 to 2 drinks a day could be considered safe for males, and about 1 drink a day could be considered safe for females. So we'll address why these guidelines have changed, and a little bit of a spoiler alert, it has to do with what alcohol really does to the human body. So we'll discuss what alcohol does to you in the short term with intoxication and the hangover, but more importantly, what it can do to your body during the long term. Like what does it do to your brain, liver, stomach, and even how it can increase your risk of certain cancers. It's going to be an ethanolic one. So let's jump into this anatomical and physiological awesomeness. So let's start with how the body absorbs and metabolizes alcohol, and then we can get into any of the negative consequences and what the new guidelines state about whether there's a safe amount that we can ingest. The type of alcohol that us humans ingest is ethyl alcohol or ethanol, but I'll just refer to it as alcohol from here on out. When we ingest and swallow alcohol, it will move down the esophagus and into the stomach. Now, if I open this other stomach, you can see this really cool inside lining called the tunica mucosa. The reason I'm showing you this is because some of the alcohol can actually be absorbed through the stomach lining and into the bloodstream. However, this is a small amount of about 10 to 20%, with the other 80% being absorbed by the small intestine. But it is important to note that alcohol absorption and how fast it enters your bloodstream does depend on the contents of your stomach, meaning the alcohol is absorbed more quickly on an empty stomach. But if, for example, there's fat and protein in the stomach, this will slow the absorption rate. And of more significance, this will also slow gastric emptying, or in other words, how fast the alcohol can move from the stomach and into the small intestine, where again, the majority of that alcohol will be absorbed. And just to give you some numbers, on an empty stomach, alcohol blood levels could peak in about 30 to 60 minutes, whereas it could take 1 to 3 hours for those blood alcohol levels to peak if there was food in the stomach. Now, once the alcohol is absorbed from the stomach and small intestine, it will go directly to the liver. And many of you have likely heard that the liver does the majority of the work to detoxify the body from the alcohol. But understanding how the liver exactly does this is important, because this will help us to understand some of the potential negative consequences of alcohol intake. Again, once the alcohol is absorbed into the blood from the small intestine and that little bit that can come from the stomach, all the blood vessels coming from these organs will funnel into a vein called the hepatic portal vein that you can see I've drawn in right there. Now, as the blood passes into the liver, some of the alcohol will move into the liver cells called hepatocytes in order to be metabolized. And here we have my brown liver cell and the brown squiggly lines here. Not to scale, but we're inside of a liver cell here. But once we're inside the liver cell, or once the alcohol gets into the liver cell, it will first convert the alcohol into acetaldehyde. This occurs in the cytosol of the liver cell, and this conversion requires an enzyme called alcohol dehydrogenase, as well as a cofactor called NAD. You can see NAD going in and then coming out as NADH. And these enzymes and cofactors will come back into our discussion in just a second, and actually throughout the whole video, so keep them in the back of your mind. But what's interesting is that the acetaldehyde is actually more toxic than the alcohol itself and plays a huge role in some of the negative impacts of alcohol. So this next conversion is going to be very important. The acetaldehyde will then be funneled into the mitochondria of that same liver cell. The acetaldehyde gets converted to acetate, and this requires another enzyme called aldehyde dehydrogenase, as well as another NAD. Acetate can then actually be utilized for energy within the mitochondria, which will require some more steps, but nonetheless, this is a much better option than having the toxic acetaldehyde building up. However, the reason I'm mentioning these enzymes and the cofactor NAD is because these will be important when we get to situations of ingesting high levels of alcohol and or chronic use of alcohol. I guess a little bit of a spoiler alert would be that we can get to a point where we overwhelm these systems, which can have some negative impacts on the body. But I do want to come back to when we absorbed alcohol through the small intestine, as well as that small amount that can be absorbed through the stomach. Yes, The blood coming from those organs does go directly to the liver, but only about 20 to 30% of that alcohol will be able to move from the bloodstream and into those liver cells for metabolism with that first pass of blood, which means about 70 to 80% of the alcohol will enter systemic circulation unmetabolized. Some of this 80% of unmetabolized alcohol will reach places that can get rid of it. For example, about 5% of alcohol can be excreted through the kidneys, sweat glands, and even through the lungs, which is how you can smell alcohol on someone's breath and how the alcohol breathalyzer test can detect alcohol. But as the alcohol circulates throughout the rest of the body, it can freely pass into almost any cell, as well as easily cross the blood-brain barrier and affect the neurons of the brain. When alcohol reaches the brain, it will interact with multiple neurotransmitters and receptors, creating disruptions in multiple brain regions. And we'll take a look at a few of these regions to help us understand some of the commonly observed effects of alcohol. The first that we'll discuss is the prefrontal cortex, which is this area of the brain that you can see here. The prefrontal cortex is involved in multiple activities, but to name a few, things like reasoning, thinking, planning, judgment, and impulse control. Suppressing this area of the brain with alcohol explains why people will often say and do things that they may not normally do without the assistance of alcohol. The hippocampus is another area affected by alcohol, and one of its functions is to form and store short-term memory, which explains alcohol's effect on memory and even the so-called blackouts that people experience at higher levels of alcohol intake. Next is the cerebellum, which is this beautiful looking portion of the brain that coordinates movement and balance. And I'm sure you're not going to be too surprised that alcohol affecting this area explains why people can stumble, lose their balance and coordination, and this overall suppression of their motor function. Also, maybe you've experienced this or noticed this in someone else. Drinking alcohol tends to make you pee more. The reason for this is that alcohol inhibits the secretion of a hormone called antidiuretic hormone that is secreted from this amazing structure called the pituitary gland. And maybe you've heard of a diuretic. A diuretic makes you urinate or pee more. So antidiuretic hormone tells your kidneys to hold on to more water, thereby creating less urine. So if you suppress this hormone with the alcohol, your kidneys won't hold on to as much water, causing more urine output and potentially leading to the dehydration that can occur with alcohol intake. The last structure I want to mention is the medulla oblongata, and this is actually part of your brainstem. And this is an area you don't really want to be suppressing much, as it controls basic vital life functions such as breathing, heart rate, reflexes like vomiting and the gag reflex, which is important to help prevent you from choking. And alcohol's dangerous suppressing effects on the medulla obviously come at higher levels of alcohol intake, but this is what is responsible for the dangerous effects of alcohol overdose, sometimes referred to as alcohol poisoning, as this can depress respiratory centers, leading to hypoventilation, coma, and even potentially death. Now, you may remember me saying earlier that alcohol can freely pass into almost any cell, which means alcohol isn't going to just affect the brain. It will also affect many other tissues and structures. For example, with the heart, it alters ion channels in the cardiac muscle cells, which can cause arrhythmias or irregular heartbeats and even cardiomyopathy. Plus, it dilates blood vessels, leading to temporary hypotension or low blood pressure. Beyond the metabolism we already discussed in the liver, alcohol induces fatty acid accumulation known as steatosis, along with inflammation and fibrosis through oxidative stress, which we'll get a little bit more into that in just a second. In pancreatic cells, it triggers inflammation or pancreatitis by prematurely activating enzymes. And in skeletal muscle fibers, it impairs contractions, leading to weakness and cramps due to energy disruptions. Alcohol can also suppress immune cells, ramping up infection risk, and it irritates the mucosal lining of the stomach, causing issues like gastritis and ulcers. Now, of course, how much it affects these tissues depends on how much alcohol is ingested and the frequency or how often someone drinks the alcohol, because the more consistently someone drinks alcohol, the more damage can be done to these tissues and can promote cell death and even boost the risk of multiple cancer types due to DNA damage through exposure to reactive oxygen species or free radicals. Now, what's interesting is that most of the structures and tissues that we just discussed don't have the ability to metabolize much of that alcohol. So most of that alcohol will pass into the cells of the brain, heart, pancreas, etc., cause its disruptions, and then move out of those cells and back into the bloodstream. And eventually will make it back to the liver where it can be metabolized. But remember, we learned that even with the first pass of blood, the liver couldn't capture every alcohol molecule. It only captured about 20 to 30% during that first pass. So blood that contains alcohol will have to pass through the liver multiple times before all the alcohol can be metabolized. And even when it's fully metabolized, many of the disruptions of alcohol can linger into the hangover for the next day. That pounding headache is partly from dehydration and blood vessel dilation that we just talked about, plus acetaldehyde has irritated your system. Nausea comes from stomach mucosal inflammation, fatigue from energy disruptions in the muscles, and low blood sugar. And that overall grogginess gets exacerbated from poor sleep and immune overdrive. But let's get into a little bit more detail about alcohol metabolism to even further understand why it can be so detrimental to ingest higher levels of alcohol. Of course, we could just say that in general, the symptoms that we just discussed become worse at higher levels, and in the case of overdose or poisoning, could even be fatal. But again, we can go into a little bit more detail than that and go back to the inside of the liver cell in this pathway to show you what happens physiologically if we continue to ingest more and more alcohol. If the liver cells have to metabolize more, we could potentially overwhelm this first metabolic pathway that we learned about. We only have so many liver cells and so many enzymes and so many cofactors. But the liver cells can activate other pathways at higher levels of alcohol intake. One is referred to as the microsomal ethanol oxidizing system or pathway, which I understand is a mouthful, but it needed to be said. But this occurs in the smooth endoplasmic reticulum of the liver cell and uses an enzyme called cytochrome P450. The names here aren't totally important, but I'm a nerd, so I had to mention a cool name again. But in this pathway, the alcohol is also converted to acetaldehyde. But another byproduct of this pathway is the creation of reactive oxygen species, which you may have heard of it as a type of a free radical. But these reactive oxygen species can damage cellular components, including DNA. Now, antioxidants that you get from your diet can neutralize some of these free radicals, but again, they can only go so far with higher levels of alcohol intake. There's also another metabolic pathway for metabolizing alcohol with organelles called peroxisomes. These peroxisomes utilize hydrogen peroxide and an enzyme called catalase, but this also converts the alcohol into acetaldehyde. So notice what we've done here. The liver recruits other metabolic pathways as we ingest more and more alcohol. And this helps to a point, but we continue to get this conversion to acetaldehyde, which we know is more toxic to the liver cells than the alcohol itself. So this next step in the pathway continues to be very important and can still get overwhelmed. So let's say we're drinking high amounts of alcohol and producing more acetaldehyde than we can recycle the NADH back to NAD, and or we've maximized all the aldehyde dehydrogenase. So you could see how this could cause a buildup of acetaldehyde in the liver, which could damage the liver cells, explaining why consistent intake of high amounts of alcohol could lead to liver disease such as cirrhosis and even increasing one's risk of liver cancer. But it isn't just about increasing the risk of liver cancer. As I mentioned earlier, there are multiple cancers that alcohol can increase the risk of, some of which include oral and esophageal cancer, where just ingesting the alcohol itself can irritate the mucosal lining of the esophagus and the mouth. And so with consistent heavy drinking, this can eventually lead to DNA damage and mutations of the mucosal cells. It can also increase the risk of colorectal cancer and even breast cancer. So with all the potential negative consequences of alcohol that we just talked about, what would happen if you quit for a month? Like some people try to do during dry January, or even if you tried to quit for good. Well, studies from 2025 show that going alcohol-free for even just 1 month can lead to quick changes within your body. Participants often report better sleep with deeper REM cycles and less waking up in the middle of the night. Mood can also significantly improve, with less anxiety and irritability, and even weight loss of about 5 to 10 pounds, because alcoholic beverages definitely add to one's caloric intake. Your blood pressure, blood sugar, and cholesterol can drop, and liver enzymes start normalizing within a few weeks. In a way, kind of giving your detox system within the liver a little bit of a break. The body actually rebounds pretty quickly, with no more dehydration headaches or foggy mornings. It's like hitting the refresh button for your body after the holidays. And if you were to decide to quit for good, these benefits will build over time. Based on recent 2025 research, you'll decrease your risk of certain cancers, like oral, esophageal, liver, colorectal, and even breast cancer. Heart health can continue to improve with lower cholesterol, as well as see even further increases with cognitive benefits of sharper memory, better focus, and reduced depression. Immunity gets a boost as well. And for heavier drinkers, this could add 5 to 10 years to your life. Quitting lets your body heal fully without just reintroducing the toxic effects by starting up again the next month. Not to mention, you could save a bit of money when you're not spending it on alcoholic beverages. But let's finally come to this question: is there a safe level or an okay amount of alcohol to drink? Well, everything we've talked about so far, the science, the research, the data, it just shows that alcohol is toxic to the body. There's no way to really get around that. But does that mean you can never, ever drink? Well, no, obviously not. As we've learned today, the body does have mechanisms to clear itself of alcohol, but there are limitations to this. But again, can we come up with some guidelines on what are considered safe amounts of alcohol? Well, it's probably not going to surprise you that there's some debate on this in the medical community, but the 2025 updates to the dietary guidelines for Americans have shifted away from giving strict daily limits, like the previous 1 to 2 drinks per day for males and 1 drink per day for non-pregnant females. Instead, they're now just emphasizing that less is better, with no truly safe level for optimal health. The World Health Organization also echoes this, that no level of alcohol is completely safe, and if you're trying to fully optimize your health, it's likely that no more than 2 drinks a week is best, and for you really big health nuts out there, maybe even none at all. And just for reference, 1 drink in the United States is considered to be 14 to 15 grams of alcohol, or about 0.5 to 0.6 ounces, which is 14 to 17 milliliters, which is the equivalent to 12 ounces of beer, or 355 milliliters of beer, 5 ounces, or 148 milliliters of wine, and 1.5 ounces, or 44 milliliters of 80 proof liquor. Now, I do want to say that the point of this video was not to be all judgy pants to anyone that drinks alcohol. The goal was to provide anatomical and physiological information so that you could make your own informed decisions about your own alcohol consumption. And hopefully you found the information in this video useful so that you could make those decisions. One of my biggest goals with teaching in my lab and making online content is to spark that love of learning in people, helping them unlock what they're truly capable of. And that's exactly what Brilliant, the sponsor of today's video, has done for me. Brilliant turns anyone into a confident problem solver. Whether you're tackling math concepts that used to trip you up or diving into computer science ideas, Brilliant helps those concepts click in a whole new way. I've personally been using Brilliant to sharpen my skills beyond biology, because it's been a little while since I've taken a math class. So lately, I've been getting into their lessons on exponential functions, and I love how Brilliant helps you excel through visual, interactive problem solving, and personalized practice that builds genuine understanding. Their courses are also crafted by an award-winning team from places like MIT and Caltech, starting you at the right level based on your background, with practice sets and end-of-level reviews personalized just for you. Now, a lot of you watching might be eyeing the medical field, and trust me, Brilliant's got you covered with lessons that build the foundation for the math and data analysis that you'll need. Plus, since most users learn on their phones, it's seamless to jump on at any time. And so if you want to start the new year off with a bang with a new intellectual goal, you can try learning for free on Brilliant for a full 30 days by going to brilliant.org/IHA, scan the QR code on screen, or click the link in the description. Brilliant is also giving our viewers 20% off an annual premium subscription, which gives you unlimited daily access to everything on Brilliant. Thanks again to Brilliant for supporting the channel. Thank you to all of you for watching our content about the human body. And of course, we'll see you in the next video.